Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to solve a differential equation using variation of parameters method. So let's get going. Problem solve y double dash minus y equal to e power minus x sine e power minus x plus cos e power minus x, or d square minus 1 into y equal to e power minus x sine of e power minus x plus cos e power minus x using variation of parameters method. So we are given a differential equation of order 2. Given differential equation, y double dash minus y equal to e power minus x sine e power minus x plus cos e power minus x. Consider as equation number 1. We can write y double dash as d square y by dx square minus y equal to RHS part. We can write d square y by dx square as d square y using differential operator d. Now take y common from these two terms, we'll get d square minus 1 into y equal to e power minus x sine of e power minus x plus cos of e power minus x. Consider as equation 2, which is in operator form. Equation 1 in operator form is our equation 2. So f of d into y equal to some function of x. Where f of d is d square minus 1 and r of x is e power minus x sine e power minus x plus cos e power minus x. Now we'll find the solution to our problem, the general solution to our problem using y equal to yc plus yp. We'll find yc, that is complementary function, using the auxiliary equation, and later using yc we'll write yp. Now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square minus 1, right? Let's replace the differential operator d by m, so that we'll get f of m equal to m square minus 1. Then the auxiliary equation becomes m square minus 1 equals to 0. Now we need to find roots to this equation. We can write this 1 as 1 square. So this is of a square minus b square form, so we can write it as a plus b into a minus b. Now equate each factor to 0. When m plus 1 equal to 0, we'll have m equal to minus 1. When m minus 1 equal to 0, we'll get m equal to 1, right? Therefore the roots are minus 1, 1. The roots are real and distinct. We know that when two roots, say m1 and m2, are real and distinct, then yc looks like c1 e power 1 root into x plus c2 e power another root into x. Now coming to our complementary function. Yc equals to c1 e power 1 root into x plus c2 e power another root into x, which gives us c1 e power minus x plus c2 e power x. Therefore, yc equals to c1 e power minus x plus c2 e power x. Let yp equal to, now replace the constants with some functions of x. Replace the constants of parameters with some functions of x, say a and b. Then we'll have yp equal to a power minus x plus b e power x, where a and b are functions of x You can compare yc with c1u plus c2v or yp with au plus bv, so that you'll get u and v, where u is e power minus x and v is e power x. U is e power minus x, v is e power x. And we can find a, b using formula. A is given by integral minus v into r of x by uv1 minus vu1, and b is given by integral u into r of x by uv1 minus vu1. So if you notice, we are having uv1 minus vu1 in both the formulas. So we'll begin with uv1 minus vu1 and later we'll find a, b, yp, and finally we'll substitute yc and yp in this formula to find the general solution. Now coming to uv1 minus v1. Here v1 is nothing but v dash or derivative of v, and u1 is nothing but derivative of u. This is equals to u e power minus x into v dash minus v into u dash. This is equals to e power minus x into derivative of e power x with respect to x is e power x minus e power x into derivative of e power minus x with respect to x is minus e power minus x. This gives us e power x into e power minus x minus into minus plus e power x into e power minus x. Since we know that e power minus x is reciprocal of e power x, so we can write e power minus x as reciprocal of e power x in both the terms. Where e power x gets cancelled, you'll get 1 plus 1, 2. Therefore uv1 minus vu1 equal to 2. Now coming to A. A is given by integral minus v into r of x by uv1 minus v1. This is equals to integral minus integral, or right minus inside the integral. E power x, r of x is e power minus x sine e power minus x plus cos e power minus x by uv1 minus v1, 2 into dx. We can write this as minus 1 by 2 into integral e power x into e power minus x sine e power minus x plus cos e power minus x into dx. Since we know that, okay, let f of x equal to cos e power minus x, then f dash of x equal to derivative of cos e power minus x is minus sine e power minus x into inner derivative of e power minus x is minus e power minus x, which gives us minus into minus plus e power minus x sine e power minus x. Since we know that integral e power x into f of x plus f dash of x into dx is e power x f of x, let's write the integrand as this becomes minus 1 by 2 into integral e power x into, I'll write f of x firstly, that is cos e power minus x. Now write f dash of x e power minus x sine e power minus x into dx, which is of the form integral e power x into f of x plus f dash of x, which gives us e power x f of x, right? This gives us minus 1 by 2 into integral e power x f of x plus f dash of x is e power x f of x, that is cos e power minus x, right? Therefore a equal to minus 1 by 2 e power x cos e power minus x. Now coming to B. B is given by integral u into r of x by uv1 minus v1 into dx. This is equals to integral u e power minus x into r of x, e power minus x sine e power minus x plus cos e power minus x by u v1 minus v1 is 2 into dx is equals to 1 by 2 integral e power minus x into e power minus x sine e power minus x plus cos e power minus x into dx, or we can write this as integral of e power minus x sine e power minus x dx plus integral e power minus x cos e power minus x into dx, right? Let e power minus x equal to some t. Now differentiate on both sides with respect to x. Which gives us minus e power minus x equal to dt by dx, right? Derivative of e power minus x with respect to x is minus e power minus x. Now bring this dx to LHS, will get minus e power minus x dx equal to dt, or e power minus x dx equal to minus dt. Now replace 1 e power minus x dx by minus dt and e power x by t in both the integrand, or in both the integrals we can say is equals to 1 by 2 into, or we can write this as integral e power minus x sine e power minus x into 1 e power minus x dx plus integral cos e power minus x into e power minus x dx, so that in the next step we can replace e power minus x dx by minus dt. This gives us b equal to 1 by 2 into t sine t e power minus x dx can be replaced by minus dt plus integral cos t into minus dt, right? This is equals to 1 by 2 into integral minus, it's integral, right? We have an integral here, minus integral t sine t dt plus into minus minus integral cos t dt. Let's now evaluate integral t sine t dt. So instead of taking t, we'll take x, variable x, and we'll find integral x sine x dx for our convenience. Integral x sine x dx. Here we are going to apply integration by parts formula. Integral u dv equal to uv minus integral v du. See, the integrand is of the form product of polynomial and trigonometric functions. So we'll consider polynomial function as u and the remaining part as dv. So we have u equal to x and dv equal to sine x dx. Here differentiate on both sides with respect to x. We'll get du by dx equals to derivative of x with respect to x is 1, which gives us du equal to dx. And here we'll integrate on both sides, which gives us v equal to integral sine x dx is minus cos x. Now apply the formula. Integral u dv equal to u into v minus integral v into du equal to dx. This gives us minus x cos x minus into minus plus integral cos x dx, right? Which gives us minus x cos x plus integral cos x dx is sine x. Therefore, integral x sine x dx equal to minus x cos x plus sine x, right? Now just replace x by t. We'll get integral t sine t dt equal to minus t cos t plus sin t, right? Since now coming to b, since integral t sin t dt equal to minus t cos t plus sin t, we can replace it in b. This gives us 1 by 2 into minus integral t sin t dt is minus t cos t plus sin t minus integral cos t dt is sin t, which gives us 1 by 2 into minus into minus plus t cos t minus into plus minus sin t minus sin t, right? Which gives us 1 by 2 into t cos t minus sin t is minus 2 sin t, which gives us 1 by 2 t cos t minus 1 by 2 2 sin t. Here 2 gets cancelled and you'll get 1 by 2 t cos t minus sin t. Since t equal to e power minus x, let's replace t by e power minus x. So we'll get 1 by 2 e power minus x cos e power minus x minus sin e power minus x, right? We got b here. Therefore b equal to 1 by 2 e power minus x cos e power minus x minus sin e power minus x. See, we got a and b. Let's now find yp. Yp is given by a e power minus x plus b e power x, right? Substitute a and b here. A minus 1 by 2 e power x cos e power minus x into e power minus x plus b 1 by 2 e power minus x cos e power minus x minus sin e power minus x into e power x. This gives us minus 1 by 2 e power x e power minus x cos e power minus x plus 1 by 2 e power x e power minus x cos e power minus x minus e power x sin e power minus x. See, here e power x e power minus x is repeating twice, or you can cancel these two terms, first two terms, or you can simplify it. Since e power x e power minus x can be written as e power x into e power minus x can be written as reciprocal of e power x, where e power x gets cancelled, you'll get 1, right? Now replace this e power x into e power minus x by 1, we'll get minus 1 by 2 1 into cos e power minus x plus 1 by 2 1 cos e power minus x minus e power x sin e power minus x, which gives us minus 1 by 2 cos e power minus x plus 1 by 2 cos e power minus x minus e power x sin e power minus x, where minus 1 by 2 cos e power minus x plus 1 by 2 cos e power minus x gets cancelled, and you'll get yp equal to minus e power x sin e power minus x. Therefore yp equal to e power x sin e power minus x. We got yp and yc. Let's now find general solution using y equal to yc plus yp. Therefore the general solution is given by y equal to yc plus yp, y equal to yc c1 e power minus x plus c2 e power x, yp is minus e power x sin of e power minus x. Therefore, y equal to c1 e power minus x plus c2 e power x minus e power x sine e power minus x is the required solution. So this completes the problem. So we have seen a problem from variation of parameters method in this video. I hope you will understand. We'll see you in the next video. Until then, bye bye.